Welcome back to Statistics with Mr. Robeson. So now that we know what standard deviation is, the average distance between all the data values and the mean, we're going to look at some properties of standard deviation, and then we're going to talk about weighted means. All right, so our properties here. So first up, S, remember S is sample standard deviation, measures the spread about the mean and should be used only when the mean is chosen as the measure of center. So if we're working with like a box plot and we're using median as our measure of center, then we're not using standard deviation. Standard deviation is only when we are using the mean. So I'm going to go ahead and underline that, only with the mean. All right, so the standard deviation can equal 0, but it's only equal 0 if we have 0 spread. So no spread or no variability is usually the word we use for standard deviation. When we talk about it, we talk about the variability, how much something varies. So this only happens if all data values have the same value. So if we had a list of numbers like 3, 3, 3, 3, 3, that standard deviation would be 0 because it does not deviate. But if one of them was different, then our standard deviation here would be something greater than 0. Like we'd have to calculate what it was there, but it would be something greater than 0. All right, and S, like the mean, is not resistant to outliers. So a few outliers can make S very, very large, just like a few outliers can change the mean a lot. Except with S, if we have an outlier on each side, the standard deviation gets much, much bigger. With the mean, it kind of cancels out. Standard deviation gets very big very fast if we have numbers that are very far away from the mean, because it averages that distance from the mean, and it involves squaring them, so it gets much, much bigger, much, much faster. So these are all useful properties about standard deviation. All right, so which list of numbers down here has the greatest standard deviation and why? And which list of numbers has the smallest standard deviation and why? All right, so 1, 2, 3, 4, 5, 1, 1, 3, 5, 5, 1, 3, 3, 3, 5, and 3, 3, 3, 3, 3. All right, so I'll give you a hint. The mean for every single one of these lists is 3. All right, so if you need to, take some time and pause and look at it, but I'll give you a hint. You actually don't need to do any calculations here. All right, so I'm going to start with the smallest, and I kind of let the cat out of the bag here with the last one, but the smallest is when the numbers are all the same. So this one, all the numbers are the same, so our S would be 0. There's no deviation at all from 3. None of them deviate, so the standard deviation here would be 0. All right, this one's definitely going to have a standard deviation greater than 0 because the 1 and the 5. This one also is going to have a standard deviation greater than 0, and this one also is going to have a standard deviation greater than 0. Now, most of the time when I ask this question in class, people generally say that the answer is A. And people are generally wrong. All right, so this looks nice and spread out because the numbers are spread evenly, like 1, 2, 3, 4, 5. But the ones that are actually farther away from the mean are the 1, 1, and the 5, 5 here, because this is 2 units away from the mean. So if we look at the deviations for each one, 2 units, 1 unit, 0 units, 1 unit, 2 units. Right? Some of these are negative and positive, but we're going to square them anyway. It's not going to matter. This one's 2 units away, 2 units away, 0 units away, 2 units away, 2 units away. So these 2's here are going to be bigger than those 2 1's. And if we did the same thing down here, we'd have 2, 0, 0, 0, 2. So this one is actually the biggest. It will have the biggest standard deviation, and then this one will be the second biggest. All right, and then this one will be the third biggest because of these zeros here, and this one here is the smallest. I've seen questions on the AP exam like this, but they show up as dot plots. Like I can remember one of them where there was just a dot plot, and like the dots were like 1, 2, 3, 4, 5 there, or 4 there, and 1, 2, 3, 4 there. And like this one was also there. It was just the dots were just right down the line, and it was like the question said which one had the greatest standard deviation, and it's the one where they're at the ends. So this bimodal distribution is the one that ends up with a bigger standard deviation than this uniform distribution does. All right, and then this other distribution has the mean, or it's unimodal and it's symmetric. So this one was smaller, and then the smallest was just straight down the middle. All right, so straight up and down, smallest standard deviation. All right, so keep these graphs in mind and keep these numbers in mind when you're thinking about standard deviation. All right, so next up, that's it for standard deviation for now. So now we're going to look at weighted means. So a catering company sells different food package deals. They want to know the mean price of the package options over the last month. They sell 3 of the $100 packages. They sell 5 of the $200 packages. And they sell 8 of the $300 packages. What is the mean price of their meal package deals? So remember, when we're finding the mean, right, it's the sum of all the x's divided by the number of data values we have. All right, well, the number of data values isn't so bad. We've got 3 of the first ones. We've got 5 of the other guys. And then we've got 8 of the last ones. So that's the total number of meal packages we have. Now we just need to find what's the total amount of money here. Well, instead of adding up 100 3 times, we can just do 3 times 100 plus 5 times 200 plus 8 times 300. All right, so we can just type that all into our calculator. If we're going to do it all at once, make sure to put the whole top in parentheses and the whole bottom in parentheses. Let's see if my calculator's still alive. Oh, missed it. There it is. All right, nope, it's off. So I'll turn it back on. There we go. We can clear this out of the way here. So on top, we've got 3 times 100. So I'm just going to type 300 plus 5 times 200 is 1,000 plus 8 times 300 is 2,400. So there's our top, and we're divided by 3 plus 5 plus 8. Enter, and there we go. Our mean price is 231, I believe, and some change. Might as well write it down, and 25 cents. All right. All right, so remember to put the dollar sign in here because we have units, so we're going to use them. So there's our mean. Voila, done. All right, so we didn't actually have to add up 103 times and 205 times and 308 times. We can just multiply it by its frequency. So this is the frequency for each one of these data values. All right, can we find the standard deviation? All right, well, we could if we wanted to. We have 2 different ways we can do this. So we can calculate it, well, actually, I guess we got 3. We can calculate it by hand. We can make one list where we have 103 times, 205 times, and 308 times. Or, I'll show you a trick with the frequency counts. All right, so let's go into Stat, let's go into Edit, and let's make some lists here. So I've already used those. I could clear them out if we wanted to, or we can just put the numbers in here. So we got 100 as one of our data values. We got 200, and we've got 300s. All right. And then right next to it, I'm going to put the frequency. So we have 3 of them. We've got 5 200s, and we've got 8 300s. So these numbers have to be in the same order. So they have to line up. 3 100s, 5 200s, and 8 300s. So now we're going to go to Stat. We're going to do one variable stats because we're still only working with one variable. The price is that one variable. All right, the list that we put it in, I believe, was L4. So L4 is second 4. And now we're going to put in a frequency list. So our frequencies were in L5. So second 5. And calculate. Takes a little bit longer. Hey, there's the same mean we just got. And there's our standard deviation, 79.32. All right, so we can calculate our standard deviation too, 79.32. All right, we can treat this as a sample, as in it's just a sample from 1 month, or we could treat it as our population. This is like all of the data values for the month. So it's really depends on how you want to think about it. And this also gives us like our 5-number summary down here as well. All right. All right, let's take a look at this one. So Flora sells different flower arrangements for Valentine's Day. She sells 12 basic arrangements for $19, 24 intermediate arrangements for $49, and 5 advanced arrangements for $99. What is the average cost of the flower arrangements? All right, so we've got a couple of options here. We can do it just the basic calculator way, or we can do it the list calculator way. So let's pull up our calculator. You can do this on your own also if you want to. You can just pause the video and do it right on your own. I'm going to start typing it in here and do it the list way for more practice. So we've got 19, we've got $49 arrangements, and we've got $99 arrangements. For the gentleman out there, it's worth it to splurge a little bit and go with the extra $99 arrangement. Trust me, she'll appreciate it. All right, 24, and then 5 of the last ones. Now we're going to one variable stats, so we're going to get out of this. Second quit. Stat, calculate, one variable stats. All right, we still have L4 and L5 as our two lists. And we're going to calculate. And then the average price is the $46.31 or 32 cents is what that will round to. Our standard deviation here is the 23. All right, and there's our answer. So we get 46.32. So our answer is this guy. I think my answer indicator is off here. That's why I'm circling it. Yeah, it's close. All right, so we can also do this from a table. So here is a table, and we have tip amounts. And I guess all of our tip amounts here happen to be whole number values, but sometimes they aren't. So a waitress chooses a random day to keep track of her tips. She organizes her tip amounts by the dollar amount and the number of tips in a frequency histogram. Find the mean and standard deviation of her tips. So this is the number of $1 tips, $2 tips, $3, $4, $5, $6, $7, no $8, no $9, but somebody did leave a 10. Good for them. Guys, it's worth it. Tip people. They need the money. All right, so let's do the calculations here. We can do this with our lists again. So stat, edit, and let's go into just clear out L4. So clear, enter, and it clears the entire list. So if we highlight the top and press clear, not delete, clear, delete is bad. It will delete the whole list. All right, so we're going to put in our dollar amounts down here because that is what we're trying to find the average of, the average dollar amount. So 1, 2, 3, 4, 5, 6, 7, no 8s, no 9s, but we do have a 10, so I'm going to leave off the 8 and 9s. We could also put them in if we wanted to and just put zeros for the frequencies. So over here we're putting the frequencies, so we have 6 1s, 10 2s, 8 3s, 4 4s, 3 5s, 1 6, 2 7s, and 1 10. All right, so we're gonna get out of here. We're gonna go to stat, calculate one variable stats. All right, our list that we're using is L4 that we want to find the mean of. Our frequencies are in L5. So if we press calculate, we get, there's our mean tip, $3.17 with a standard deviation. So this was a sample because she picked a random day of about $2.02. So her mean tip was $3.17. So X bar, I don't know if I have them. Nope. X bar is $3.17, and that is in dollars. And the standard deviation was 2 something, 202. So our standard deviation was $2.02. All right, how would we describe this distribution? So what's the shape of this distribution here, guys? It is skewed to the right. So it has a tail to the right. So we would say that this is skewed right. All right, so that means the mean should be greater than the median. Did we check out what the median was? So let's check out what the median was. So if we arrow down, there's our median, 3. So sure enough, our mean is bigger than our median. So 317 is bigger than exactly 3 by 17 cents. All right, so that's because this $10 tip is skewing it up this way, and probably the $7 and maybe some of the 6 ones too. All right, so now which is better? The mean is having the mean and standard deviation of a distribution, or the 5-number summary? Well, the real answer is it depends. So if we have a symmetric distribution, so if it's symmetric, there's another M in there, I know it. Then the mean and standard deviation might be better. So X bar and S would probably be the better ones. All right, particularly if it's something called normal. If it's a normal distribution, then we definitely want mean and standard deviation. But if it's not normal, like if it's a skewed distribution or something like that, so otherwise, I mean, it kind of depends. All right, with the 5 number, we can get outliers. All right, we can find outliers. With the mean and standard deviation, we don't really have any way to do that. Like we can, eyeball it and be like, 3 standard deviations away from the mean seems like a far way away, but we really don't know for sure. All right, so the 5 number summary is better if we want to find outliers. The mean and standard deviation is better if we have a symmetric or a normal distribution. All right, so that was properties of standard deviation and working with weighted means. That's it for this section 2.4. So check out the Sporkle quiz and check out your homework on Google Classroom. All right, see you later.